Here's an image of an early model sewing machine never modeled in CAD. If one of its components breaks, you could use a 3D scanner to reverse engineer the component. So that's what we've done. Now in this example, the main arm was 3D scanned and saved as an STL file. So let's open that STL in Solid Edge. In this example, we'll look at two methods of reverse engineering. The first method will be used to reverse engineer tools the reverse engineering tools to clean up the mesh in the model, as well as develop a couple of B-rep surfaces. For example, in this design we may have a need to delete the top center hole in the boss it sits on. With the simple fence select, we can identify the area that needs to be deleted. Notice that it deletes the mesh on both sides of the model. To fill or repair these areas, the fill hole command works great as it identifies these open areas automatically. Using available options, it quickly closes these areas. There are also ways to develop B-rep surfaces from the mesh model, either using the automatic method or manual method. With the manual method, you can paint a specific region, such as the cylinder on the inside of this part, using the paintbrush. Now, the one thing to notice is you don't have to paint the entire region of the cylinder, but instead roughly paint the height and then the circumference. When finished, click on the Fit command to convert the painted region, in this case, to a cylinder. Simply identify the filter or the region that you just painted and let it create the cylinder. What we can do is we can turn off the mesh body and you can see the cylinder was created. Maybe you also need to create a plane. To do so, simply replicate the previous steps. Identify the region by painting the face where the plane is going to lie. Then fit a plane to that region. When finished, you can see both the cylinder and the plane. As we turn off the mesh model, you'll see both of those. Now, of course, further development of surfaces can be continued if needed. It may be that only a couple of surfaces are needed for use in placing the component into an assembly, but it's up to the user how far they need to go. In this case, the Trim Surface command is being used to simply trim and clean up these two surfaces. The second method, or second option in working with scan data, is to use convergent modeling techniques to modify the mesh data. Here is the same model we just worked with, already saved in Solid Edge. Now you'll notice the hole is missing at the top, which was previously removed. First, let's go ahead and place the original hole with a slightly larger hole. Then we can add a dimension to make sure the hole is in the correct position. And of course we can adjust that if we need to. Finally, we can extrude the hole through the model. Now remember, this is mesh data, but the modeling techniques are the same. Notice after the material removal that the hole remains as mesh data. Not only can we remove material, but also add material to the model. For example, we might want to add a part number. To do so, we can simply place some text, which will represent this information. So we can go ahead and key in that text here. Key in the number we want, set the orientation, and finally click to place the text. Once placed, it can be extruded into the model. Just identify it, extrude it down into the model. The final step in these operations is to remove material from our model using another component that this model will interact with during operation. The second design body was created in synchronous mode, but was converted to a mesh body in the ordered mode. Let's first use this second mesh body to remove material from our model. There you can see it removing the material. Now what's cool about this method is that we can drive the dimensions of this synchronous cutout from a dimension, making these types of operations easy to modify. With convergent modeling techniques, Solid Edge provides the capability to add and remove material from a mesh model seamlessly, and in return giving the user more control over their designs.